Hello and welcome to section 10.7, which is on the areas of circles and sectors. So the area of a circle, we should remember, is pi r squared. My example, what is the area of a circle with a 42-inch diameter? The first thing you need to realize here is that they're giving you diameter and not radius. And so you'd need to divide the diameter by 2, so the radius is 21. So just like always, start with writing down your formula. Area equals pi r squared. We're going to use 3.14 for pi. My radius is 21 and it's 21 squared. So 3.14 times 441. All I need to do is multiply those two. So 1,384.74 square feet is my area. Remember, that area has to be labeled with this 2. It is two-dimensional. The sector of a circle is a region bounded by an arc of the circle and the 2 radii to the arc's endpoints. And I will show you an example here in a second. Theorem 10.12, area of a sector of a circle, the product of the ratio, the measure of the arc over 360, and the area of the circle. So you're going to take the portion of the circle that they're talking about and take it times the area of the whole circle. So for example, a circle has a radius of 4 inches. What is the area of the sector bounded by a 45-degree minor arc? And leave the answer in terms of pi. So my area is going to be the 45-degree arc over 360. That tells you what portion of the circle it is. And then you're just going to take that times pi r squared. And so this can be reduced to 1/8. You're going to leave the pi symbol there because it wants it in terms of pi. My radius is 4, so 4 squared. 1/8 times pi times 16. We can go ahead and reduce this. 1/8 of 16 is 2. So because they want it in terms of pi, I will leave it 2 pi, and then I have to put my label of square inches on the end. So you're basically figuring out what fraction of the circle they're talking about. That's where the 45 over 360 comes into play. They're not talking about the area of the whole piece, they're just talking about the area of one, or of the whole circle, but of one piece. Like if I was talking about this circle right here, like if I was trying to find this little piece of pie right here, it would be similar to this. So segment of a circle, a part of a circle bounded by an arc and the segment joining its endpoints. So, in other words, from there to there, its endpoints. And so if I was just talking about this little piece in here, the part of the sector that is not included in that little triangle there, that is the segment. Okay, and so we're going to do an example here. What is the area of the shaded segment? We're going to round it to the nearest tenth. So on this one, we need to know that that's 4 meters. The radius is 4. So the first thing I need to figure out is, because this is a right angle right here, and this is making a right triangle, the piece that I don't want to include, I only want this shaded part. Okay, so the area of a triangle I need to figure out first. So it will half of base times height, and since the radius is 4, it's just going to be half of 4 by 4. Half of 4 is 2. 2 times 4 is 8. So 8 square meters is the area of that triangle. That's the part I don't want to include because it's not shaded. Now I need to go ahead and find the area of the whole sector. So the area of that whole sector would be, because there's a 90-degree angle right here, you know that this is 90. So it would be 90 out of 360 times pi r squared. So times pi r squared. 90 over 160 reduces to 1/4, so we can use that. So 1/4 of 3.14 times, my radius is 4, so 4 squared. 1/4 of 3.14 times 16. 1/4 of 16 is 4. So all I should have to do is take 4 times 3.14, and that gives me 12.56. That's for that whole piece, though. That's for this whole chunk. I don't want the whole chunk, I only want the part that's shaded, so I have to take away the area of that triangle. That's why I figured that out. I don't want that part, it's not shaded. And then it did say, I believe, round to the nearest tenth, so I need to round that. So my area then of that, just of the shaded segment there, would be 4.6, and again, because it's area, we would label it with square meters. So bring that knowledge with you, and we will talk about it more the next time I see you. Have a good night.